Okay, everybody, let's move to the chapter number 8. Chapter number 8, estimation. In hypothesis test, the purpose was to make a decision about a perimeter in terms of it being greater than or less than or not equal to a value. But what if you want to actually know the perimeter is? You need to estimate. You need to do estimation. There are two types of estimation: point estimator and confidence interval. Okay, again, confidence interval is easier, and point estimator is the other one. Okay, first, chapter 8.1, basics of the confidence interval. I'm going to copy this one to online group. Okay, and here, a point estimator is just the statistic that you have calculated previously. As an example, when you want to estimate the population mean, mu, the point estimator is the sample mean, x bar, to estimate the population proportion, p. You use the sample proportion, p hat. There is a symbol hat, like wearing a hat over the head, p hat. In general, if you want to estimate any population parameter, we will call it theta. You can use the sample statistic, theta hat. Point estimators are really easy to find, but they have some drawbacks. So backs, not perfect. First, you have a larger sample size, then the estimate is better. But with a point estimator, you don't know what the sample size is. Also, you don't know how accurate the estimate is. Both of those problems are solved with a confidence interval. Okay, I got it. Then definition, confidence interval. There is where you have an interval surrounding your perimeter, and the interval has a chance of being a true statement. In general, a confidence interval looks like theta hat plus minus e, where theta hat is the point estimator and the e is the margin of the error term that is added to the subtracted from the point estimator, thus making an interval. Okay, interpreting a confidence interval. The statistical interpretation is that the confidence interval has a probability 1 minus alpha, where alpha is the complement of the confidence interval of containing the population parameter. As an example, if you have 95 confidence interval of p between 0.68, 0.73, then you will say that the probability, there are 95 chance the interval 0.95 to 0.73 contains the true population proportion. Okay. This means that if you have 100 intervals, 95 of that contain the true proportion, and 5% will not. 5% will outside of the range. The wrong interpretation is that there is a 95 chance that the true value of p will fall between 0.65 and 0.73. The reason that is interpretation is wrong, that the true value is fixed out there somewhere. you are trying to capture it with this interval. So it is the chance is that your interval capture it and not that the true value falls in the interval. Okay, again. So this is the chance your interval capture it, not the true value falls in the interval. Okay, it's a little bit strange to explain this. There is also a real-world interpretation that depends on the situation. It is where you are telling people what number you found the perimeter to lie between. So your real world is where you tell the values your perimeter is between. There is no probability attached to this statement. This probability is in the statistical interpretation. Okay. The common probabilities used to confidence interval are 90, 95, and 99. Yes, similar to that. Similar to this one, we can call that the confidence interval is 90, 95, and 99. In other words, we can set the label 0.1, 0.05, 0.001, sorry, 0.01. In other words, the confidence interval is different, okay? Those known as the confidence interval. The confidence interval and the alpha level are related. As I mentioned, 0.05 is the most common use, the alpha value. Okay, they are related. For a two-tailed test, the confidence level C is 1 minus alpha. And this is because alpha is both tailed and the confidence interval is the area between those two tails. As an example, for two-tailed test, alternative hypothesis HA is not equal to, with the alpha equal to the 0.1, the confidence interval will be 0.9 or 90%. You will have, if you have one tail test, then your alpha is only one tail because the symmetry and other tail is also alpha. So you have two alpha with both tails. Okay, let's move to this one. Example 8.1.1, stating the statistical and real-world interpretation for confidence interval. Suppose you will have 95% interval for the mean age a woman gets married in the year of 2013. That is between 26 and 28. State the statistical and real-world interpretation of this one. Okay, the question is, suppose you have a 95 interval, confidence interval for the woman get married is this one. Statistical interpretation, there are 95 chances that the interval 26 smaller than mu, smaller than 28, contains the mean age of a woman gets married in the year of 2013. Real-world interpretation. The mean age of the woman married in 2013 is between 26 years old and 28 years old of the age. Okay. Question number 2. Suppose a 99% confidence interval for the proportion of Americans who have tried marijuana. Sure, in Thailand it's not illegal, but in some countries like the Holland, Netherlands, that's okay. Is 0.35. Between that and 0.41, state a statistical and real-world interpretation of this statement. There are 99% chance of the interval between 0.35 and 0.41, okay, contains the proportion of Americans who have tried marijuana as of the year 2013, real-world interpretation, the proportion of Americans have tried marijuana as the year between 0.35 and 0.41. 0.41. Okay. And here is the interesting. For example, a confidence interval on the width. For example, this one, the mean is close to the 5. When a similar situation, when we have the 99% confidence interval, the range covered is larger. When the confidence interval is shrinking to the 90%, the covered range is smaller. Okay, it's reasonable. And this one, effect of sample size on the width. Let's check here. Now look at the sample size affect the size of the interval. Suppose figure 8.1.2 represents confidence interval calculated on a 95% interval. A larger sample size from the representative sample makes the width of the interval narrower. The larger the sample size and the width of the interval narrower. Okay, like this one, the sample size is 1000. It's very narrow. The range is very narrow on a 95% interval. Okay. Larger sample sizes are closer to the true population, so the point estimate is pretty close to the true value. Why? Because what can I say? That is, when we have more information, for example, 1000 of the samples is closing to the population. Okay, let's move. Homework. Okay, and this one. Chapter 8.2. This one is maybe we can skip this one. Let's move to the next. And here, chapter 8.3, one sample interval for the mean. Suppose you want to estimate the mean height of Americans, or you want to estimate the mean salary of a college graduates. A confidence interval for the mean will be the way to estimate those means. Okay. Confidence interval for one population mean, T interval, state the random variable and the perimeter is in words. X equals random variable, mu, the mean of random variable. Okay, get it? Then state and check the assumption of the hypothesis test. The first, a random sample of size n is taken. Second, the population of the random variable is normally distributed. Though the t-test is fairly robust to the assumption, if the sample size is larger. Okay, this means that if the assumption isn't met, but your sample size is quite large, over 30, then the results of the t-test are valid. And find the sample statistic and confidence interval. Mean, the sample mean here, then we will, the population mean is in the center, and on the left limit, there is sample mean minus E. On the right limit, there is sample mean plus E, where E equals TC times S divided by square root of n. X bar is the point estimator for mu. TC is the critical value where degrees of freedom, and S the sample standard deviation, and the sample number. Okay. Then 4, statistical interpretation. In general, this would look like there is a C% chance that the statement X bar minus E smaller than population mean, smaller than sample bar plus E, contains the true mean. Okay, then number five, the real world interpretation. This is where you state the interval contains in the real mean. Okay, let's move. Yeah, the similar question. We did it last class. Example 8.3.1, confidence interval for the population mean using the formula. A random sample IQ, 20 IQ score of famous people, yeah, we did it last class, was taken information from the website of this one, then use the random number generator, pick up 20 of them. The data are example 8.3.1. This is the same data set used in the second one. Okay, find 98% confidence interval of the IQ of a famous person. Wow, let's do some calculation. The first one, there are 20 people, their IQ are selected and listed here. First, state the random variable and parameter in words. X equals IQ score of a famous person. Okay. Second, state the check the assumption for a confidence interval. A random sample of 20 IQ scores was taken. This was stated in the problem. No problem. Okay. B, the population of IQ score is normally distributed. This was shown in example 8.3.2. Okay. Then number 3, find the sample statistic and confidence interval. Sure. Sample statistic here. Try to calculate. We did that last class, so we don't need to do that again unless you want that. X mean, the mean is 145.4. The sample standard deviation 29.27. Okay. Now you need a degree of freedom. The similar way, 20 minus 1, that will be 19. That will be 19. And the C, which is 98%. Now go to the table 8.2. Go down the first column. Degree of freedom here. And in the confidence interval, 98. And degree of freedom is 19. In the cross, we got a number 2.839. 2.839. Okay, let's check the table. Thus, TC 2.39. 2.39. If you forgot the definition of TC, move to previously. TC is the critical value where the degrees of freedom, and now in this question, the degree of freedom is 19, and check the confidence interval 98%. We got the TC is 2.539. Okay, and now we do the calculation. E that is equal to TC times S, sample standard deviation, divided by the root square of the n. That is 2.539 times 29.27 and divided by square root of 20. Let me show you how to do this. Okay, here is my calculator. Just do it. 2.539 times 29.27 divided by square root of 20 and click answer, enter. Yeah, 16.617, close to the 6.6. And now the question, the population mean, we try to find the population mean because again, it's impossible for us. We don't have enough money. We don't have enough time. We don't have enough labor. It's impossible for us to find a population, maybe millions of millions of people. But we have the chance to take some samples, some useful samples, and we try to use the samples to calculate the real population mean. And now we got the estimation. The average minus E. The average minus E is smaller than the average. Then it's smaller than the average plus E. Again, the average 145.4 minus 16.6. The other side plus 16.6. Thus, we got the answer 128.6, sorry, 28, smaller than the population mean, smaller than 162. And there is a 95 confidence interval that 128.8 smaller than the mu and smaller than the 162. In this range, we have 98% confidence that there will be between this range. About what? About the IQ score of this one. The mean IQ score of a famous person is between this one. Okay, get it? Let me check any. Okay, how about let me have a, please calculate this one. Yeah, you can continue use the information previously and calculate this one. 3 minutes. Yeah, start now. Okay, and I'm going to give you 12 useful websites. They are confidence interval calculator. Okay, for example, if I use this one, the website applications, I just type the information as the question. The average is 145.4, the sample size 20, and population standard deviation. Yep, after I calculate, if I import something inside from inside, and we got the information like this. See, the same confidence interval 128.75 and 162.02. So you can use this one. Sure, during the exam you are allowed to use this, but I don't encourage you to use the solution directly. Instead, I try to ask you to check the information one by one, like this question. Then you will know the principles. No principle. Okay. Okay. The bell is ringing. Any question? Okay. No more questions. See you next week. Have a nice Monday, everybody.